So thanks for the intro. I'm really happy to be here. Unfortunately, it doesn't work. Give me 1 second, because I just had to mark that. No. I tried that. Maybe the battery is out of control. Okay, here we are. It's good to be here in Romania. It's been a long time. When I was 16 and 17, so 2 years in a row, I've been here for vacation. And I was really looking at this picture and thought, okay, it would be so cool to be back in one of these little things. And I really remind me of one of these days that started to rain, and like we had to escape the rain, and like 20 people fit into this booth, and there were like many sheep around, and we stayed there for like hours to escape the rain. And yeah, so actually I think it was not there, but somewhere over here, but it doesn't matter. But now we're here in this great building, and yeah, I'm trying to keep you awake with some crazy stuff I do. But about myself, so that's me. I'm Martin Kleppe. You can find my stuff at m1k.com. So it's a collection of crazy minified JavaScript pieces. You can follow me at mk on Twitter. Or you could check out my regular website. So this is the company I'm working at. It's UB Labs. We are doing, so my daily job is not about like minifications, more code, but working with really huge amount of code. So currently I'm parsing like gigabytes of data and trying to like calculate implications for driving cars about like 100,000 per second. And so it's totally opposite of what I'm going to show you here. And it also has some relation, but you're going to see that later. So I will try to introduce you to this. It might be hard to recognize what it is, but if you see it in an animation, it's like an ASCII character that's trying to go off. And I'm going to speak about code dwarfing. So this is a kind of like code sport and artsy thing where you try to minify code, and the dwarf pattern is somehow used as so the strokes that you try to get into the hole. So the hole is the problem you try to solve, and the strokes is like the keystrokes, and you try to solve a problem with a few characters as possible. To give you a short preview, what we will see at the end, I hope you can read it. This is what we like try to build at the end. But before we get started, just a really quick preview to get your teeth. I'm going to start with there. So this is somehow how I get involved to JS1K. I'm not sure who's ever submitted something to JS1K. My God. You should do it. Like everyone should do it. It's a really fun competition. So the idea is that you have this kind of HTML template. You have a canvas and a script tag, and then in the script tag you have B, C, and A. A refers to the context, B to the body, and C to the canvas. And then you have like exactly 1024 bytes of JavaScript left to do whatever you want. So that's the root. It's now the 5th year, maybe. I'm not quite sure, 4th or 5th. And in the first year, I tried to hack a small poker game in that. So I thought, I'm quite good, but then I realized, okay, the other competitions are really amazing. One thing that came out this year, and this was the winner this year, it's like a fractal, and you can move things around and play with this interactively. Another cool thing is this 2084 game, but like 2 side by side, and you can play it. And I think, in my opinion, the most impressive piece is still the winner of the first year. It was a jump and run game, and you see on top, okay, there's a ball moving around. You can jump to the next stages. You can collect these coins. You have these enemies that you're not allowed to touch. You have these pink things that are going down, and below you get the idea of the source code. So it's really impressive what you can pack into it. It's not done by me. It's by Marin Haverbeek, and he wrote a really nice article. And this somehow opens like my eyes how to really get things down to a minimum size. While seeing this, I prepared a talk for JSCamp EU in Berlin last year, and we all had these questions. Okay, what does this or that fit into that amount of characters? And so I tried to search for something and ask myself, okay, does the world fit into 1,000 characters of JavaScript or 1,025? And I've seen this piece of code somewhere. It's from Monsieur Ido. It was a Ruby script that you can run on the terminal, and if you execute it, it spins a bit, and if you could execute it again, it spins one more time, and so on. And I thought, well, this is pretty cool, but I saw two problems here. So the first one, okay, it was way too big. And the second problem for me was written in Ruby. So I had two options here. First one would be to boil it down, so take the existing code, try to understand it, transfer it into JavaScript and try to shorten it. And the other option was to rewrite things. And I decided to not look at the code, but just get this as an inspiration and try to put it at my own. Okay, I'm going to show you how to do it, just how I work with this kind of stuff. First, the layout. So the idea is we have characters, and then there's the world inside. Should be some more ASCII art. To do this, we have to cut a hole in between. So we use these comments to leave the space, and then we put something around. Here's an eval, and there's a string. And the string is like self-remembering, and on a timeout it executes itself so that we get the animation. So this is the basic idea. What we need now is the map itself inside of the code. So I try to scale it and came up with this thing. You got an idea of how the continents look here. And there was a problem, because when you really count the pixels, you'll see, okay, these are 320 characters, and I might need some code to make this rotating thing. And then I think it was one of the hardest parts to get this really down. And the idea was here, okay, instead of saying pixel, 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 not pixel, and so on, I simply count the differences, or how many times a pixel or not pixel repeats. So we have the 6666, 6 times a pixel, then it's 5 times no pixel, 1 time a pixel, and so on. And we can reduce this to a single number. And if we combine this into arrays, we only have 129, 92 characters. And instead of writing every single number, we can put them all together and use high integers like that. So we're down to 104 characters. And this was still too much, and I thought, okay, how can we get this down even more? And there was a method that you usually don't, or you use it, but not in that way, because if you call toString with a high integer, you can use any kind of any character of the alphabet and get it down to 90 characters. So this was quite good, from 300 something to 90. One issue that we have is we have to access it somewhere in an array. So I did it like that. It's 104 characters now. But instead of saying, okay, this is a string, comma, this is a string, comma, this is a string, we simply could use, for example, a pipe in the string and then split by that pipe. And who knows how to even improve that? Some idea? Okay, no? We could use like a for example. So it's not a string, so we get rid of the two quotes and use like a number that's not in the original string and like save these two characters here. Yeah, the final like thing to resolve this and get back the full bitmap as we see before is like 163 characters, and we have now like access to these and can look over that to draw it on a screen. But we don't want to have it like two-dimensional, but we want to have it three-dimensional. So instead of just painting it like that, I want to have it like that somehow. And this sounds like complicated, but actually I've done this before for another thing called 140 bytes. So this is a method where you can pass x, y, z coordinates, the rotation thing, and it turns you to new coordinates. And you can even reduce this down to 82 characters. So this is the whole logic needed to like rotate the whole thing. And if you put this together with some more aspects, you get code that might look like that. So, I'm not going too much into detail. If you have time, try to read it. You might learn a lot. And actually, it looks like that. So we have the surrounding script tags. There's a dot before the first script tag to make it the body, because if you skip this, you can't like write things because the browser thinks it's in a head. And I did some ASCII art that looks like the Earth. Yeah, that's it, and if you execute it, it's there. So it's even color, here you see there's a font color thing to make the characters look different. You have the thing in the middle that's like rotating. And yeah, that's it. You can see it here at M1K, it's left right. But to continue with that, I'm trying to give you an idea of how to like shrink things together. And if you do this kind of demos, you always start with an HTML file and somehow play with HTML5, but the HTML5. So really use things that are not allowed, but actually work in the browser. And if you like, this is maybe a default template that you might have seen. If you take this, then we can think, okay, what is really needed here to execute JavaScript on an HTML file? One thing that we doesn't need is the doc type, so it works even without a doc type. We don't need the HTML tag, this surrounding, so get rid of that. Head, if you don't want to title in there, we can get rid of this thing would be the title itself. We don't need that. Then we have the script type, text, JavaScript. Many people still write that, but actually we don't need to define a type and just use script here. It looks way shorter now. But if you see this on load, we call the init method that is defined before. We could simply like move things about and put the script into the button of the body, and it executes like after the content was defined. Or we could do it by simply putting everything inside of the onload handler. And if you do that, we also can get rid of the closing body tag, because the browser itself is like closing things for you if you forget it. And that looks like it's the shortest version, but actually you don't even need the quotes here. And do it like this, and maybe the shortest version of it executing HTML5 with JavaScript is that one. So this is it's not valid, but it's working. Yeah. Okay, but it's poor, so it doesn't do a lot. What we usually want to do is like modifying the HTML itself. So this will showing up a pop-up, an alert window. If you want to write something in a document, we could use document write. There's only one thing that you have to keep in mind when doing this in a loop, that it's always appending stuff to the document body. So when you want to replace things, like I do with the animation, then you need to write something like document body in our HTML is 1 and the next loop is 2 and so on and so on. It looks short, but actually there's a shorter way to do it, because document body is quite long. And what we can do is define an ID on the body, which doesn't need any quotes, just E. And what most people don't know, if you define an ID in HTML, it's globally accessible as a global variable. So you can say e.innerHTML without saying document get element by ID. So simply use this. If you use b as another variable, it's getting away, but if you just use it like that, it's still working. So this is quite interesting here. If we want to make it look nicer or more like monospaced, we need something like a pre-tag in here. So we append a pre-tag to make it really fixed with characters. And if you look at this, it's actually not working, because the browser sees the bracket thing was called the greater, it's greater than sign, and it tries, okay, this, it thinks, okay, this is the tag, and it actually renders this into the browser. So to make it work, we still have to get back the codes to make it work. But next thing. Okay, we can save a character here, because this is also something many people don't know. We can focus on that, because there's ID, E, and then there's a space, and if we move this over here, we don't need a space, because there's a code. So we save this, and okay, it's only that size. Okay, if you focus on that, you might even use it more by putting the pre-tag at the beginning. So instead of saying body, write something, we just skip the body and write the pre-tag with an ID, and then put a script behind that saying B and whatever. So this is even shorter now. And if you want to focus on pre, so pre is monospace, some people don't know this. This is the ticker type tag. You should use this like more, not only me, but you can use it still. It's like the pre-tag, but it works differently with the white space, so it doesn't like display every white space character that we have in there, but it shrinks it down. And I think it's an inline tag, so you have to manually do the mark shrinks. And if you don't care about monospace, we can use something like an E for italic, but then it's like italic, or B, but then it's bold. But we can use X, for example, so you can choose any character as a tag. And if it doesn't exist in the specification, it simply runs as like block level element. Yeah, that's it. Just the basics here. Yeah. And also some basics about how to minify JavaScript. So, but this is really the basics. If you see this, you know, okay, I can only use one variable and use the comma to assign more. If we don't care about if it's like valid or not, we can just go without the var. We then can, for example, if you use math multiple times, we save var n as mask, and then replace that to get it down. If we have this method, we can define it as R and then call R. And now things are getting more interesting. So this is something you should know. But we might also like save the string random and then access this from the math element. So this will still execute the method. It looks like it's some more characters, but actually if you like expand the first brackets a bit and move that thing down, it might save you some characters. So you define and execute it in one place and then execute it in the next place. Or do it even better, use it, we all like it. It's totally evil, but could save you many characters. And yeah, if we have the width, we can skip the curly braces if you like putting commas in between. And we can use the alt technique that we just learned to like save the second random thing. Oh, actually the quotes are missing. No, it's not. It's not in this case. Yeah, it's true. So this is correct. So it gets the random from the math because it's in this width context and stores it at R. And we can like reduce this to that line. Yeah. That's it, basically, how you get into. And there's a really long list of things that you can use to minify your code. It's based on this 140 byte competition thing. And all the things that are mentioned on the wiki are also valid in JavaScript, so it's not things you can't use. Yeah, that's it. I showed you some examples from the 1K contest, and I want to show you more examples, and people think about, okay, can we go like below 1K, maybe half of 1K, or maybe just some characters to do things. We've seen this like double game here. And after it was released, we came together with a group of people and reduced it down to like half the size, and it looks like that. And if you don't care about tables and use ASCII and tab stocks, it's only like 351 characters. And you still can play it, so it doesn't look that nice anymore, you don't have the animation, but you can still play it. And the code looks like that. I'm not gonna go into the detail, but it's a full HTML page you need to have this game running in the browser. And usually things start like that. Someone is putting a tree, but the usual suspects here asking for something. This was at the conference last month in San Francisco, and someone said, okay, there's a Flappy Bird JavaScript version without the HTML, but how about getting it down? And it turns out you can do this also in less than 400 characters. And it looks like that. It's still hard, yeah, so it's as hard as the original game, but you can manage it. Yeah. So this was like below half the K. And if you focus on this is something like JSCamp. So you have an output and three inputs to input the HTML, the CSS, and the JavaScript, and it will display that in real time as you type. And the whole thing is less than 265 bytes. Looks like that. And if you go through this, because it's really short to read, we have this on input, and on load. So on load, render stuff, on input, it changes stuff. We have the iframe that's actually used to like display things, and on load, it renders two different text areas. And if you change this or on input of one of the text areas, the first child, which is the iframe, gets populated with the source code, which is the HTML, some scripts, and some style. So that's what Mr. REM spent the last years on, maybe. So this is if you really think what's the basic idea, you can really get it down to minimal characters. Okay, this was like 265. You can get this down even more. So you remember the fractal thing that was 1K that you can move around. P1K, he was one of the judges. He created That one is the how's it called? Dragon curve fractal. If you zoom up, so this is a nice looking pattern, and this is done only with that code. So he uses a body, a canvas again, and then by simply repeating a rotate and fill rect and translate action, he can render fractals in the browser. It's not animated, but still really impressive. Yeah, that's it. Okay, and yeah, maybe people think about this number. Is there an HTML file? If you know some, do you? No? Okay, you can still work with that amount of characters to get something in the browser. The code is there. It's quite easy to read, so it's a paragraph, and if you move the mouse over it, I'm going to show you. So it's a paragraph in IDB that you can access it, and if you move the mouse, the HTML is extended by a random character which renders a kind of maze in the browser. This is quite impressive. The origin of this was that it's from the, let me do it right, Commodore 64. It was a sample program. I think the author is not even known, but they use it as a to get you into programming. And it was even cooler than what we saw before, because it just continues to execute that first line. So it says 10 print, I can't read it from that here, then it gets a character with a random thing that outputs these 2 lines, and at the end it says go to 10, so it repeats itself, and it continues to generate a maze on the screen. It's really impressive thing. And if you think 45 minutes is quite a lot to talk about a topic like this, there's a book that you can order on 10print.org, and it talks about this very single line in more than 200 pages. So they focus on every aspect. Why is it 10? Why is it 8? Why they use this kind of characters and so on, how our maze is done and so on. It's really, if you're interested, this is really good stuff from the MIT press. And if you're talking about characters, strange characters, we have these in JavaScript, if we get rid of all the numbers and have characters, we still have these left. And if you select, for example, these 8 random characters, there are people that use this set to create programs. One thing is that it's a language called brainfuck, where you have 8 different characters to execute stuff. And if you run this in the brainfuck interpreter, it outputs hello world. So this is the basic example here. Okay, 8 characters, quite cool. There was a discussion on snackers.org, which is a crazy forum, and they talk a lot about security aspects. And the question was here, okay, how many people, how many characters do we need in JavaScript, actually, at the minimum, to execute something? And it turns out that only 6. I created a site, JSCamp.com, where I fixed some issues that were in the original project. And it's hard to understand, but I'm trying my best now to explain how it works. So if you say, if you have square brackets, it's an array. If you say not square bracket, it's now false in JavaScript. If you say not an array, it's true. And this is crazy because it's only square bracket, but it's an array, and you access the first element of this array, which is not present, so it's undefined. And if you actually add another array with the plus sign, it converts into strings. So you have false, true, undefined in this case. It's funny, eh? Okay. Another thing that you can do if you don't want to focus on characters but on numbers, you say plus, plus gets into a 0. If you say plus, not plus array, it's a 1 now. And what you can do is like adding 1 and 1, then you have 2, and so on and so on. So you get any number that you like only with these characters. And they are not even like these round brackets, so the penalty is only plus ampersand and square brackets. Okay, and if you combine this, it's getting more interesting. So we had this before, we can convert anything into a string by adding an empty array, and we can put this in parentheses now. It still outputs string, and we can access the first character here, so the F, for example. And if you don't want to use numbers here, we can actually use the thing that we used before and still get an F. So in that way, it's possible to collect some characters, the F from false, the I from undefined, the L from false, the true from true, the T from true, the E from true, and the R from true. And if you read this from top one, you see it's filter. And if you add these characters, still with like only the 6 different characters, we get a string filter. And we can put this string like behind the array and have the method filter of the array. And then we can like filter this array, or we can go even, so we can execute it, or going even further and collect some more characters from there, like the COL, so on and so on, and get the constructor, which is actually a function. And this serves as something close to eval. So you can put any code as a string to this method and it executes. And you can, for example, put the string error1 into there that you collect from somewhere and execute code. Still only with 6 characters. If you have to do it manually, it's like a lot of work. So, and really, if you copy this, there's no interpreter needed. If you copy this one by one into the console, it like alerts more. If you want to do it by hand, you can use this tool on JSCamp.com that I set up. So you type in the code you want to execute, and it returns the characters. You can paste this and doing crazy XSS attacks on cool websites. Go to JSCamp.com, try it yourself. It's really fun. Okay, let's get on with that. So it was quite big when I released it, and people doing pull requests now to get this down for some reason, I don't know why. It's now down to 1,200 characters. And what I did, let me check the next layer, what I did. I got it down even more, but I am using a trick, so I use the curly braces from the object, just cheating for now, but you'll see in a second why this is cool. If you have this object plus an empty array, you get the object string, so you can do like shortcuts to several characters. And I was preparing another talk, and I looked at this pattern and thought, okay, can you read this? No, you can't, no? Okay, this is better maybe. You see a pattern, so it's a lot of this opening and closing square brackets. And we can replace these 2 characters with a single character, for example x, and put this as a variable at the beginning and short this a bit. So this is like only using x's instead of empty arrays. Next step, I can't read it from that, I have to go here. Next step would be to analyze more patterns, for example, the not plus x and the plus x and not x, and the not x are there multiple times, and we can simply replace this by a different variation of x, so uppercase, some like more characters, and get it down to that. And you see it in the beginning, it's just assignments. So we only now use x and the other characters in the assignment and the semicolon to separate things. And you can still put this into the console and it gives you an error one. I call this triple X for some reason it's somehow related to JSFAC, so that's it. And if you think about this, then you come to a point where you think, okay, why should we use this? Why not using umlauts and some of your the characters of your language, and have this executed? So this still gives you the same output. We can do this with katakana, Japanese characters. So this is L1 still. So I'm the only one who translated, or the first one who translated JavaScript into a foreign language. If you look at this, it's somehow, if you look at this too close, you do something. There's a little problem here from my side, from my point of view. If you use katakana or like hiragana or kanjis, they're like not the same size as regular characters that we use in our alphabet. They're like 1.5 size. But I want to like shape things and was looking for another alphabet and found the Cyrillic alphabet, which is quite useful to do things, especially when you're trying to introduce a talk at the US and have to explain that you're from the Eastern Germany side and stuff like that. And what you can do, so this is how it looks when you like use this alphabet, and what you can basically do, because it's only one, it's always a character, and the character and special characters, you can add spaces anywhere you like. This, for example, every second character is a space. You can do layout like this, and I wanted to do something like that. So this is what I call the Death Star, because if you really look close, in the heart there's the XSS space, and this is only the code the JavaScript used to execute. On the top there's something, if you make a lowercase you get that's the body unload, and then there's the title itself, so I can't pronounce it, but it's Death Star in Russian. And if you open this HTML page, so this is a valid HTML page with Cyrillic letters only and some XSS, it gives you this. So this was quite fun project. You can phone it here. I have like 7 minutes left. And I prepared something for this conference, so it's always have my hands on the machine and trying to do something new. And I want to show you a project called Mandelcode. I'm not going really much into detail, but just want to show you some aspects of that. And I call it Mandelcode Equine. When we click to zoom, and if you open the HTML, it looks like that. So this is the HTML file. And if you look close, there's the pre-tag, the script. And it's the same order. So this is the JavaScript itself. So it's in the shape of a Mandelcode. So that was the basic idea. And itself it's a coin. It's a special pattern in programming, esoteric programming style. A coin is a program that outputs itself. So it outputs its own source code to the browser in this case. And to do this, let's shrink this down. So we have the pre-tag, the script tag, and to do it really easy is to use text content and apply the inner HTML, the same thing. So in this case, the page runners itself. Text content is something new I learned about, because you can't access inner text in Firefox. That's why you have to use text content, which is available in all browsers. If you do this, actually only the script tag, or the things including the script tags are rendered. So we have to add the pre-IDP with a Uline thing to it, and that's what you get when you open it in a browser. So this is what you actually see. And in the middle you have this like thing that you know what to do, and once you click it, it starts to animate. So this is now like a minute going really deep into this fractal, and you see this changing patterns. It's like the code itself is only like 300 or 400 bytes, but like arranged. And if you really come close and closer, then certainly you reach a level where the precision of JavaScript floats isn't not that good anymore. And you see it's gonna change, and this will break the whole thing. So this is like when you really get a deep dive into JavaScript, what you get. Yeah. And that's it. Go to mk/mandel-code. You might be the first one. I'm gonna tweet about that and share it. And I'm almost done with my presentation. The only slides that I have left is why are people doing that? And there are many reasons. So I like it somewhat like an art, but maybe it's fun for me or fun for other people. And it also forces you to find your own limits, like about what you know and what's possible. So you set yourself a limit and try to hit that limit, and you work really hard, and sometimes you think, okay, it's not possible, then you talk to other people and you're trying to hit that limit. One thing, so the code sometimes looks really ugly, but actually when you develop this kind of applications, you really have to focus on things. So you focus on a small piece of code, you arrange it really nice to still make it readable, and just at the end compress it. And in my opinion, it really helps me for my daily job to work on projects, on large projects that look like with a high complexity, but it helps me to focus on the small parts. Language, yeah, you learn a lot of about JavaScript that you've never thought about, and you discover things that maybe no one has discovered before. You read about the specs, what's possible also for the HTML specs, and really get the last 20% that usually is not necessary in your job, but at the end it helps you to write better code, in my opinion. And what I also really love about that is like you come together with people from everywhere that speaks every kind of language, but in the end we're all speaking JavaScript, and people are helping out each other, coming up with new ideas, and it's like a connection between like the whole world. So people from French, from Russia, from the US, from Germany, from everywhere, like coming together to work on these kind of projects. Yeah, and that's the reason I am happy to be here, and I have to say thanks